Okay, so last time, recall, because it's going to be a lot of similar stuff, just different formulas. So last time, recall, we did arithmetic sequences, and what makes them arithmetic is they have a common difference. Remember how we find that is we work backwards. We do 9 minus 7, which is 2. 7 minus 5, which is 2. 5 minus 3, which is 2. Therefore, our common difference is 2, so we're adding 2 to get from one term to the next. Now remember, this was a formula that allowed us to find the nth term, any term in the sequence, right? This formula will always work for arithmetic. And then when we started adding them, we started finding sums. We had to know the number of terms we were summing up. That was n. And it was n over 2 times a sub 1 plus a sub n, where a sub 1 was the first term that you were summing up, and a sub n was the last and final term you were summing up, right? Now, all today, the difference is that we're not going to have arithmetic, but geometric sequences. Geometric sequences have what's called a common ratio. Ratio means division. So just like we work backwards here, we work backwards here as well, and we do division. 32 divided by 16 is 2. 16 divided by 8 is 2. 8 divided by 4 is 2, and 4 divided by 2 is 2. So that means we're timesing by 2 each time. Does everybody see? So that makes it geometric. It does have to be multiplying by the same thing every time to make it geometric. And then this is, write this down, this is the formula to find the nth term in the sequence. Any term in the sequence will be a sub 1 times by r raised to the n minus 1, where r is the common ratio and a sub 1 is the first term. So let's write out our general formula that would recreate 2, 4, 8, 16, 32. So that'd be a sub n is equal to a sub 1 is 2, and we're timesing by 2 raised to the n minus 1. This formula will recreate that. Easy, right? So you'll have to have that formula memorized as well. So once again, I am making a list for you of things to go into the test knowing. All right, so let's practice. You don't need to write this one down. You're going to get more out of this one just by watching. So it says write the nth term formula for the sequence. So first of all, you would check, is it arithmetic or geometric? Because most of the time they won't tell you on the test. So if you try to do subtraction, there isn't a common difference. So you'd move on, is it geometric? 24 divided by negative 12. Negative 2. Negative 12 divided by 6. Negative 2. 6 divided by negative 3. Negative 2. So we're timesing by negative 2 each time, right? So we'd say a sub n is equal to a sub 1, which is negative 3. Then we're timesing by negative 2 raised to the n minus 1. There's your general formula. Now let's practice this, because I am confident that they will have one where they ask you to write a recursive definition. And if you miss this, probably you're missing the easiest one on the test. But a lot of people miss it because they don't know what recursive definition means. So just a reminder, a recursive definition is a way for someone to rewrite this sequence, even if they don't know it, by a formula that's written in terms of the previous term. So with recursive definitions, you have to tell them where to start. A sub 1 is negative 3. So you say starting with negative 3, any term in the sequence will be equal to a sub n minus 1. You take the previous term, and then what do you do to it? Times by negative 2. So how do we get negative 12? We take the previous term times by negative 2, don't we? You say take the previous term and times it by negative 2. It's that simple to write. It's literally just what do you see happening? Does that make sense? Okay, moving on. Now if I ask you to find the 100th term, you would definitely use this formula, because this one you can plug directly in. Okay, so just a couple examples. The first few are really easy. I wouldn't think you would need to write them down. I think you'll probably get more out of watching once again. I'll tell you when I think it's hard enough for you to write down. So it says find the first 3 terms if a equals 3 and r equals 2. Now remember, if they were to say 8, it's the same thing as a sub 1. So I start with 3, then the next term would be 6, the next term would be 12. Very good. Okay, so now it says find the 15th term. You're not going to write it out 15 times. Instead, you're going to create a general formula. A sub n is equal to, a sub n is equal to a sub 1, which was 3. We're timesing by 2, and then we're raising to the n minus 1. So then now we'll plug in 15. A sub 15, that means the 15th term is going to calculate to be 3 times 2 raised to the 15 minus 1. Ready? Click, 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 calculate. That's the same thing as 3 times 2 to the 14. And then just for quickness today, don't worry about saying the word 1,000. Just go 2630. 4915. 4,915. Yeah? What? 49152. 49,152. Yeah? Yeah. Awesome. That would be a 15th term, right? There's a sub 15, people. Okay. Now, why is it so big? Think about this. Geometric is exponential. Aren't we timesing by 2? It's getting larger and larger pretty quickly, so just keep that in mind. Okay, let's do this one. Once again, it's still not hard enough for you to write down. It says find a sub 7. So you say this is geometric, because what's our common ratio? This divided by this divided by this divided by this. Isn't that all -5? So we're timesing by -5 each time. So you say a sub 1 is 2, we're timesing by -5, and let's plug directly in. Won't that be 7 minus 1? So that's 2 times -5 to the 6. Now guys, look, anytime your ratio is negative, it has to be put in parentheses in your calculator. Otherwise, your calculator will not take the negative to the power as well, and it needs to be. So this would be a positive 1. And negative to an even is positive. That's why I knew it was positive. No one just sit around and wait for him to calculate this whole lesson. You all need to do it. Okay, thank you. I appreciate you. I'm just saying, you've got to be annoyed. I want to punch your peers in the face. They just wait for you to. Okay. I'm showing you this one for a reason, everybody. Watch. So you still don't need to write it down. Still really straightforward. I just want to point something out. This is geometric. And let's pretend it wasn't, like, what's our R here? 1/3. Now let's pretend that one was pretty easy to just see. What if on the test they give you one that's not so straightforward to see? Let me show you how you do the math, right? You would say this divided by this. Let's just do that for now. So that would be 1/81 divided by 1/27. Isn't that how you find it? So then you would say dividing fractions is easy as pie, flip the second fraction and multiply. So we're going to be timesing by 27/1. So then we have 27/81. That is your R. Then they both divide by 9, don't they? So this divides by 9, it becomes a 3, and this divides by 9, it becomes a 9. Well, then now it's still not completely simplified. Don't they both divide by 3? So then 1/3, right, everybody? Okay. All right. Find the 8th term. So now we're doing a sub 8. So we say find a sub 8, which is equal to a sub 1 was 1, times by 1/3, raised to the 8 minus 1, and then you would calculate it. Now understand this. Everybody watch, because this throws people for a loop. If you start with fractions, you need to end with fractions. Therefore, typing it directly into your calculator is only going to give you a decimal. So we have to do this by hand. Let me show you how to do it by hand. It's actually really easy. It really, truly is. But you do have to know what you're doing. So look. This is 1 times by 1/3 raised to the 7th power. Agreed? So that's 1 times 1/3 times 1/3 times 1/3, 7 times. How many times have I written it? 1, 6, 7. How do we multiply fractions? Straight across. What are all the 1s times by 1? 1. Then we have 3 times 3 times 3 times 3 times 3 times 3 times 3. That you could type into your calculator, which is 3 to the 7th power. Where'd he go? See, it's 3 to the 7th power. What is it? 2. Say, wait, what? That's how you get full points. If you roll the decimal by chance, you just get marked off 1 point or so. Does that make sense, everybody? If you start with decimals, you can put decimals. If not, put a fraction. You guys are doing great. Pretty easy so far. Okay, this is where it starts to get a little bit more thinking involved. It just takes, remember how last time, a lot of times it took a couple steps to actually get to be able to calculate the answer? This is the first example of that. So it says the third term in a sequence is 63/4. The sixth term is 1,701/32. It says find the fifth term. So what I would do is kind of draw myself a picture. Here's a sub 1, 2, 3. Isn't that what we're given? So 63/4, then it's a sub 4, a sub 5, then a sub 6. We don't know. Oh, no, we do know a sub 6 is that, correct? And it says, what's the fifth term? So we're trying to figure out what this term is. Now, there's many ways to do it. Remember last time when we ran into something like this, we took this and we plugged it in right here. So we said a sub n is 63/4 is equal to a sub 1. We don't know what a sub 1 is, right? We don't know what our r is either, correct? And then raised to that, we do know what n is though. It was 3. So then 3 minus 1 right here is 2. Then we set up another true statement with this one. We said, okay, so a sub 5 is, oh no, we don't know a sub 5. We're at a sub 6, sorry. So we know that that is 1701 over 32 is equal to a sub 1. We don't know. We also don't know what r is. But we do know that was the 6th term, so 6 minus 1 is 5. And then we had a system of equations, correct? That's how we did the arithmetic one. Now right here we have a system of equations in a sense, but now it's going to be, it's not a linear. Like remember with arithmetic, it was a linear system of equations. So really continuing solving this is harder than just setting up a different truth statement, but I'm trying to decide if we should just, should we just do a system like we did before? Sure. Okay, so I'm just trying to decide which one I want to put on which one. So I'm going to write this. Okay, let's see here. So 1701 over 32, and then that's equal to a sub 1 times by r raised to the 5th. Let's think about the algebra here. Okay, so a couple different things. Is it true that their a sub 1s are the same? Yeah, right? And it's true that their a sub 1 and their r's are the same. That would make sense. A sub 1 and then what we're timesing by is the same. So we could solve by a couple different methods. There's just a lot of different algebra that would work out here. So what I would probably do is let's get a sub 1 alone here and then replace it with this a sub 1 or either or, you know, substitution. Just substitute in. So get a sub 1 alone here. Or here, it doesn't matter. Get a sub 1 alone. What would we have to do? Divide by r squared, correct? Or easier said, can't we times both sides by 1 over r squared? So we're going to times by 1 over r squared, times by 1 over r squared. So now look right here, we have our truth statement. A sub 1 is equal to, when we multiply straight across, we get this. 63 over 4, don't we? And then r squared on bottom, because we multiply straight across. You see why I have 4r squared? So now we'll take that and substitute it into the other problem wherever there's an a sub 1. Now what would be our truth statement? Sorry, I'm trying to decide if I need more room. That would be 1701 over 32 is equal to, instead of a sub 1, we have 63 over 4r squared times by r to the 5th. Now the algebra is actually working out not too shabby here. So let's simplify, meaning we're trying to solve for r now, aren't we? So all of our equation has r in it. So now from here, let's simplify. Okay, so I'm trying, if you think about it, what's r to the 5th divided by r squared? R to the 3rd. And won't it be on top? There's 5 r's on top and 2 on bottom. It'll divide out to be r cubed on top. So we have 63 over 4, and then we have times by r cubed. Okay, let's get r alone. Times by 4 to both sides, correct? That would undo that. And then divide by, so then, or times by 1 over 63. So won't that just be like the reciprocal, guys? Do you guys see what I did? Okay, so now take 4 times, calculate that for me, somebody. 4 times 1701 divided by 63 times 32. A bunch of people do it because this could potentially calculate wrong if you're not typing it in really carefully. 3.375 is equal to r cubed. Is that what other people got? Okay, then how do we get r alone? Cube root it. Now if you take an even root, like a 4th root, wouldn't I need to put a plus or minus on r? But it's an odd root in this instance. So cube root, so what is r? 1.5. So now we know what our ratio is, 1.5. So now we can go, and our ratio, what we're timesing by, is 1.5. Now can't we find what a sub 1 is? So our truth statement would be 63 over 4. Let's plug it into either equation and solve for the other, a sub 1. So we have 63 over 4 is equal to a sub 1 times 1.5 to the 2nd power. So now how would you get a sub 1 alone? Divide by 1.5 squared. Divide by 1.5 squared. So ready? Type that into your calculator. We need a sub 1 for our formula. $63 divided by 4 divided by 1.5 squared. You get 7. All right, now we can plug it into our formula. It says, what's the fifth term? So you'd say a sub 5 is equal to a sub 1, which is 7 times by 1.5 raised to the 5 minus 1. Perfect. So now we can calculate that. Now, technically, your calculator, unfortunately, is going to give you a decimal. So on the test, if you wrote a decimal, you'd get it right. You just get marked off a point. So do you guys care enough to change it to a fraction real quick or no? Not really. Okay. Then what's the decimal? Over what? Sweet. How would you have to do it? You'd have to go like this. 1.5 is 3 halves. You'd have to know that. So then you would do 7 times 3 halves times 3 halves times 3 halves times 3 halves, because there's 4 of them. Then you just multiply straight across. That's how they're getting that. Does that make sense, everybody? Well, it started with fractions, right? So on a UVU exam, they'd want an answer as a fraction, but once again, I wouldn't mark it off wrong, because it's not wrong. If you put a decimal, I just mark off 1%. So it might not even be worth it to you to change it, but it might, you know. Okay, great question. All right, sweet. All right, so now we're going to actually start adding these up. So just like with arithmetic, there's a special formula to find the sum. This is the special formula to find the sum of a geometric series. So it says S of n. Now, once again, n is the number of terms we're summing up, just like with arithmetic. So it's equal to a sub 1 times by 1 minus r raised to the n, all over 1 minus r. It's quite important, for the most part, to put your denominator, the 1 minus r, in parentheses. Now, a lot of times it's really smart to put your r up here in parentheses, because if your r happens to be a negative, like if we're timesing by negative a half, you need to make sure your negative 1/2, even the negative, gets raised to the power here. So you'll see what I mean. We just got to be really careful with our parentheses. So it says find the sum of the first 5 terms. So it's geometric, so we'd be using this formula. I call it the ugly formula, just so when you hear me say that. So we have a sub, so we're summing up 5 terms. So S of 5, that means the sum of 5 terms is equal to a sub 1 is 1. And we have times by 1 minus, what is our common ratio? If you didn't know, you'd do this divided by this divided by this divided by this. So that would be 0.7. Does everybody see how our R is 0.7? So we have 1 minus 0.7 raised to the 5th, all over 1 minus 0.7. Now, I didn't put the 0.7 in parentheses because it wasn't negative 0.7. If it was, I would put right here in parentheses. All right, so everybody practice typing it in, because honestly, people can write this down and then they just can't type it into their calculator right. And a lot of times that would get you write down the wrong answer. For the most part, UVU wants us to mark off half of the full points of the problem. So it'd be a shame to not be able to type it in right. I'll type it in and tell you what you should get. That way you know if you're typing it in right. You should get 2.7731. Now, fun fact for you, for sums, it is always appropriate to write down a decimal. You never have to write down a fraction for a sum. So, did you all get that? This adds up to be 2.7731. Okay. Okay, so looking at this one, everybody, this is something to note here. So look, this is the same thing as find the sum. Isn't that what this means? Find the sum? That's just written in a different format. This is no different than the problem I just did. It's just written differently. So now notice this says find the sum. That means add up the first to the 5th term. So aren't we summing up 5 terms? Yes. And then remember how we can do that is the top minus the bottom plus 1. So 5 minus 1 is 4 plus 1. But 1 through 5th term would be 5 terms. Now notice right here, this is something to note. If the formula right here is geometric, so So if the formula, if this is a geometric series, what this formula will always be right here is exponential. Because exponential things are when we're timesing by something each time. So notice this has the form a sub 1 times by r raised to the n minus 1. Do you guys see how that makes it geometric? Because on the test, if they give you this, you have to know which formula should I use. Should I be using arithmetic or geometric sum formula? So notice, just a reminder, geometric will be exponential, and arithmetic, look, arithmetic would be linear. So if you saw this on the test, you'd go back to the other sum formula. But this one is exponential. Okay, so now we would use our exponential ugly formula. So we're summing up 5 terms. That's equal to, how do you find the first term? Plug in 1. So then that would be 7 times negative 2/3 to the 0. Isn't negative 2/3 to the 0 1? So then 7. Then times by 1 minus our r. What's our r in this formula? A sub 1 times by r. Isn't that your r? So negative, oh, it's negative. I better use parentheses. Negative 2/3. And we're raising that to the 5th power. And then that's all over 1 minus 2/3. So let's all type that bad boy in real quick. Oh. I get 4.75308,642. Did anyone else get that, or did I type it in wrong? Got it? Okay, cool. All right, good stuff. All right, now here is where we got to keep rolling with this for a minute. Okay, so everybody focus in, because this could either be really confusing or not so bad. Okay, so far in our lessons with arithmetic and geometric, we have technically only found sums of what have been called finite series. Now what has made our sums finite was we knew where to start and stop adding. That makes it finite by definition, because you know where to start and stop adding. So right here, if you saw this on the test, you'd say this is arithmetic because this is linear. And you'd say we're starting at the first and adding at the 5th term. Then you'd use this formula. You'd say the sum of 5 terms is equal to 5 divided by 2 times a sub 1. What was the first term? You'd plug in your lower limit. So then that would be 0 plus the last term would be plugging in the upper limit. So that's 10 minus 2, which is 8. So then there would be your sum. Does everybody see? Now this one, you'd say we're summing up the 1st through 10th term. It's geometric, so we would use this formula. So then you'd say, so that's s of 10, and then is equal to a sub 1 was 2. We're plugging our lower limit. That makes it go away. So we have 2 times by 1 minus 3 raised to the 10th. 10th all over 1 minus 3. Everybody good so far? That's what we learned. Now once again, look, this is still finite. We have 1 plus 2 plus 3 plus 4 plus ... 12. We know the start and stopping point of where we add. So then we'd say the sum of how many terms here? How many terms are we summing up here? 12, aren't we, everyone? And it's arithmetic, so that's why I'm using this. The sum of 12 terms is equal to 12 over 2 times a sub 1 plus a sub 12. It's finite. We know the start and end. Okay, same thing here. It says find the sum of the first 10 terms. Because it tells you the first 10 terms, you'd say the sum of 10 terms, it's finite. You knew that we were only summing up 10 terms. A sub 1 was 2 plus 1 minus our r is 2 raised to the 10 all over 1 minus 2. Okay, so what? Those are all finite because we knew the start and end. Now what if the sum is infinite? What if we're trying to find the sum of an infinite series? Can we do it? So let's explore that. So just looking right here, still not needing to necessarily take notes, just watching so that this clicks for you. So now look, it says find the sum of 1 to infinity. That's making it now infinite. So now this goes on forever. And then right here it's linear, so it's arithmetic. So now look at what that looks like. I've written it out in its actual form instead a little bit. to get you a visualization of what's going on. So we're taking and plugging in lower limit. So plug in 1, plug in 2, 3, 4. So it's like 2 plus 3 plus 4 plus 5 plus 6 plus ... and it goes on to infinity forever. Would we be able to find a sum here? No, like we would be adding forever, wouldn't we? Infinity never ends. It's a place. You guys understand that? So would we be adding till we were old grandmas and grandpas? Yes, and then we die and then our kids would be doing that. Like we couldn't find the sum. So there is no sum here. So if it's arithmetic and it's infinite, you cannot find the sum. We would never know when to stop adding. Now let's look at the sum from 1 to infinity. Now it's exponential, making it geometric. And I've written this out here. So notice we're timesing by 2 each time. 2 plus 4 plus 8 plus 16 plus 32 plus ... and it goes on to infinity. Would we ever know when to stop adding there? It's getting bigger and bigger without bounds, correct? So wouldn't we be in that same situation where we would never know when to stop adding? So you're right, we cannot find the sum here. But look at another example of a geometric infinite series here. We have the sum from 1 to infinity of 2 times a half raised to the n minus 1. So notice in this one, it is infinite, it goes on forever. But look what's happening. 2, now it's going to plus 1, plus a half, plus a fourth, plus an 8, plus a 16th, plus 1 over 32, plus 1 over 64, plus 1 over 128, plus, and it's getting smaller and smaller, isn't it? Do you think we can or can't find a sum here? So those of you that are saying we can, why do you think we can? So you're saying that this arrow's pointing, but eventually it's pretty much 0. You're correct. So you're remembering from last year. You're right. This is getting so small that eventually we're just adding 0. So because it's getting smaller and smaller and eventually going to 0 pretty much, it's pretty much obviously because it can't be exactly 0, but pretty much we're at 0.0000000000000000000000001. And now does that really matter to your sum? No. So eventually you approach 0 so you can find the sum. So what do you see the difference between this geometric and this geometric? When can we versus can we find the sum? Yeah. So you're saying if it's getting larger and larger, if you're timing by something greater than 1, it's getting bigger and bigger, you can't find the sum. It's getting smaller and smaller. If it's a fraction, then if it's a fraction that's between 0 and 1, then we can find the sum. Good. Okay, that is by definition this. So it says, this is where you'd want to write it down. You can find the sum of an infinite geometric series if and only if your ratio is smaller than 1. Now that has nothing to do with negatives. You do not look at the negative. So that's why I put these absolute values. You only look at the r without the negative. So if your absolute value, if your ratio is between 0 and 1, you can find the sum. Essentially, it's easier just to think out. If it's getting smaller and smaller, it'll approach 0. Therefore, you can find the sum. But if it's getting larger over time, it will get larger with no bound. Therefore, you can't find the sum. If you can find the sum, you're going to use this formula. This is the formula for the sum of an infinite geometric series. Notice I call it the pretty formula because look how easy it is. All you have to know is a sub 1 divided by 1 minus r. You don't have to know the number of terms to sum up because you don't know, right? It's technically infinite. Yep, so this is the sum formula for infinite geometrics that you can find the sum of. So let's use it. Look how easy it is. You say, okay, 1 to infinity, it's infinite. Can I find the sum? Yes, because isn't our r equal to a third? So isn't it getting smaller and smaller over time? We're timing by a third each time. So we're cutting it into thirds. So it's getting smaller and smaller over time, approaching 0. So you say, I can find the sum. So s is equal to a sub 1. Isn't a sub 1 plugging in the 1? So then if I plug in 1, I get 0 as an exponent, making this 1. So we get 2 all over 1 minus our r is a third. So then our sum is 2 divided by 1 minus a third. And we get 2 divided by 3/3 minus 1/3, which is 2/3. So we get, the sum is 3. It really will add up to be 3. Pretty much. Questions on that? The sum is 3. Okay. Now we just have to learn 2 quick words here. So we just learned that at times you can find the sum and at times you can't if it's infinite. So it says if you have an infinite geometric series and you can find the sum, it's considered convergent. So everybody write that down, because they will say to you, tell us if this converges. So convergent means you can find the sum. It's converging to a sum. So if your ratio is less than 1, that means it's getting smaller and smaller. Therefore, these values approach 0, so we converge to a sum, and it was this formula. So just if you can find the sum, it's converging to the sum of a sub 1 over 1 minus r. Now, if you have an infinite geometric series and you can't find the sum, then it's considered, instead of convergent, it's considered divergent. So basically, if your r is greater than 1, if we're getting larger and larger without bound and it's infinite, we can't find the sum. So you'll say no sum, it diverges. So diverges is the no, converges is the yes. All right, so then, do you have those words written down? Diverges to a, no, it diverges, converges to a sum is yes. Okay, so this is a really good, I think, example for you to have in your notebook. This is an example of just putting it all together. This could be arithmetic, they could be geometric, could be finite, they could be infinite. These are such good examples to have written down for yourself. Because it's not, you're going to have to really decide when you see these problems on the test. So it says, find the sum if possible. So notice it doesn't tell you if it's infinite or finite. You have to look and see. It doesn't tell you if it's arithmetic or geometric. You have to look and see. And it doesn't tell you which formula to use. You have to know. So I'll try number 1. 1, 3, 9, 27. So the first thing is it arithmetic or is it geometric? Is the pattern arithmetic or geometric? So it's geometric, check. Okay, is it infinite or finite? It goes on forever, so it's infinite. Well, if it's an infinite geometric, it possibly could have a sum. Is it getting larger and larger or smaller and smaller? Larger and larger, so there's no sum. It diverges. That's what you need to write from here on out. If there's not a sum, it diverges. Does that make sense? Okay, let's go on to example number 2. I'd write that down for myself. 1 plus a third plus a ninth plus a 27 plus a dot, dot, dot. Okay, but first of all, you check, is it geometric or arithmetic? Geometric, then it is infinite, isn't it? And it's going on forever, that's what makes it infinite. And then you're right, isn't it getting smaller and smaller over time? So you say it converges, but you can't just say that. It converges to, and then don't we use the quote pretty formula? So sum is equal to a sub 1, which is 1 over 1 minus r, so 1 minus the third. So if you wouldn't mind getting me, what is the sum there? 3 halves. So the sum adds up to be 3 halves. You just found the sum. Pretty easy. Okay, let's look at number 3. Is it geometric or arithmetic? It's arithmetic, isn't it? Aren't we adding something the same thing every time? Is it infinite? No, because we know the start and the end, so it's finite. So can we find the sum? Heck yes, we can. And don't we use this formula right here? All right, now the first thing we have to know for this formula is how many terms are we summing up? Now this is a sub 1. Isn't this a sub n? If this is a sub 20, we're summing up 20 terms. So don't we have to first go figure out what that term that is? We'd have to use our formula. A sub n is equal to a sub 1 plus n minus 1 times d. Remember with these, a lot of times it takes both formulas. So we know a sub n is 42. 42 is equal to a sub 1 was 2 plus, we don't know what n is, that's what we're trying to find, n minus 1, but then we're timesing by, well, no, not timesing, sorry, we're adding 2, correct? So then 2. So now solving for n, we would subtract 2. 40 is equal to n minus 1 times 2. Don't we divide by 2 next? Right? Divide by 2, everyone. 20 is equal to n minus 1, therefore n equals 21. So now we can go use our formula. So we're doing the sum of 21 terms, which is equal to 21 divided by 2 times by the first term, which is 2, plus the last term, which was 42. So if you wouldn't mind quickly telling me what that sum is. This one? We are n over 2 times a sub 1 plus a sub n. But the first thing, Isaac, was the problem of we didn't know what n was. Does that make sense? So we had to hurry and push pause and then come back. Just like, remember how last time almost every problem took both formulas? We had unknowns. Does that make sense? Okay. What is the sum, please? 462. Cool. Okay, awesome. I wanted you to see it all together because it's like, honestly, it's easy when you see them by themselves. But when you get it all together, people kind of confuse the stuff. Okay, write this example down for yourself. I'm telling you, if you need it, I promise. It's going to be weird at first. So we have 1 minus a half plus a fourth minus an eighth plus dot, dot, dot plus negative 1 over 50. So your first thing is to decide arithmetic or geometric. It is geometric. Is it finite or infinite? Finite. We know the starting and stopping points. So you're using the ugly formula. Now we need to know how many terms we're summing up. Now this is the a sub 1. Now look, this is a sub n, isn't it? You see how we're in the same boat we were in here? The math just is a little bit harder than the example above. So let's go write what we do know. So you first say, I need to hurry and quickly figure out how many terms I am summing up. So let's go ahead and do that. So to do that, remember, you'll use your other formula, not the sum formula. We've got to figure out what n is before we can use the sum formula. So then you go back to this formula. A sub n is equal to a sub 1 times by r raised to the n minus 1. Okay, let's plug in what we know. We know a sub n is negative 1 over 500. Let's plug that in. Negative 1 over 500 is our stopping point. That's equal to a sub 1 was 1. Then we're timesing by, what are we timesing by each time? Negative a half. And then we're raised to the n minus 1. Now we're trying to solve for n, just like here we were trying to solve for n. But to get n alone, we have to be really careful and not forget how logarithms work. This is solving an exponential equation. So look, this is base negative a half raised to the n minus 1. Can you bring n out of the exponent with division? No, it takes a logarithm, doesn't it? So just a reminder of the steps to solve. You isolate the base. So let's divide both sides by, let's get rid of the negative as well from both sides. Does everyone agree? So let's divide both sides by negative 1. So now your true statement is positive 1 over 500 is equal to, we have base 1/2 raised to the n minus 1. Now don't be that person that divides by a half, because that's not how we undo bases. We have to log base a half both sides. Now this takes the change of base formula. So we have log of 1 over 500 divided by log of 1/2. We just did the change of base formula because how else can we calculate that? And that's equal to n minus 1. So now type into your calculator log of 1 over 500 divided by log of a half. These will always come out to be perfect whole numbers. This is an nth term we're trying to find. So type that in for me. What does this calculate to be? It should have come out perfectly. Not something went wrong. It's probably my rounding. Maybe I didn't, I'm trying to think. Should have calculated perfectly. I think our calculators are just probably not quite there. It usually will come out perfectly. That was because I made up this problem. And it's, let's just say it's 9. But it usually really should count. Like if it was 8.7, something went wrong somewhere. You know what I mean? Just so you guys know. Okay, so we have 9 is equal to n minus 1. So then solve for n. Add 1, don't we? So n equals 10. So now we can go use our formula here. So now we know we're summing up 10 terms. So we would say the sum of 10 terms is equal to a sub 1, which was 1, times by 1 minus, and then remember, since our r is negative, we're going to put that in parentheses, negative 1/2 raised to the 10 all over 1 minus negative 1/2. I get 0.666. Wait, isn't that like the sign of the devil or something? Did you get that, or am I typing it in wrong? 0.666. Sweet. And then there's more to it, but I just don't have room to write it. Cool. Okay, any questions on that? Okay, last one. We're actually almost done with the lesson. You guys are doing so awesome. Really, stick with me. We're almost there, but refocus. But okay, I can do this. I can refocus. 1 plus 3 plus 5 plus ... Isn't it infinite? Isn't it arithmetic and infinite? So we can't. Divergent. Yeah, divergence bad. Convergence, smiley face. You can't. Right. Bad means can't. So, okay, cool. Last two examples are quick, too. They're so quick. So, look. Find the sum. This is like on the test. Find the sum. So, is it arithmetic or geometric? Geometric. Okay, so you can find the sum if it's infinite sometimes. Can we on this one? What's our R? 1/5. Isn't 1/5 less than 1? So, it converges. And then isn't that the nice formula? The sum is equal to what's a sub 1 over 1 minus 1/5. So that would be what? You got 5 halves? Sweet. Is that what you got? For real? Okay, cool. Moving on. Okay, this is the last example of the day. Find the sum. So is it arithmetic or geometric? Geometric, and then what's our R? 7/5. Aren't we timesing by 7/5 each time? So can we find the sum? 7/5 is like 1.4-ish. Isn't that greater than 1? Can't find the sum. Wait, I can't think it diverges. So no sum. Sweet, that's the end of the lesson. So go start practicing these on the homework. You guys did amazing. Do you want to watch the revision?